the area enclosed by the circumferences of two concentric circles is 346.5 centimeter cube. The area between these two circles A is 346.5 centimeter square. If the circumference of the inner circle is 88 centimeters, calculate the radius r of the outer circle and this radius r of the inner circle. So they have given the circumference of the inner circle, that is 2 pi r is equal to 88. By using that formula 2 pi r is equal to 88, we can find out r, this small r is equal to 88 divided by 2 pi. After calculations we get r is equal to 14 centimeters, and they have given the area of this shaded region. So that means area of the bigger circle minus the area of the smaller circle will give the area of the shaded portion. That is, A is equal to, A means area of the shaded region is equal to the area of bigger circle, that is pi r square, minus the area of the smaller circle, which is minus pi r square. So we can write A is equal to pi r square minus pi r square, that is equal to A is equal to pi into r square minus r square. When we know that the A is given as 346.5 centimeter square, r we just now find out that is 14 centimeter. By substituting all these values, even for the pi 22/7, we get r is equal to 17.5 centimeters. Two circles touching externally, touching this circle externally. The sum of their areas is 130 pi square centimeter. Sum of the area of this circle plus this area of this circle, that is A1 plus A2 is equal to 130 square centimeter. And distance between their centers, distance between the center of this and this distance is 14 centimeter. Then find out what is the radius of the bigger circle and radius of the smaller circle. Now they were given the distance between the two circles, that is r plus r is equal to 14 centimeters. They also given the area, sum of the areas of the two circles, A1 plus A2 is equal to 130 square centimeters. Area of circle A1 is pi into r square. Area of this circle is pi into small r square, that is pi r square plus pi r square is equal to 130 pi. We can take out pi as common, then r square plus r square is equal to 130. A1 plus A2 is equal to 130 square centimeter. The A1 is pi r square, A2 is pi r square, that is equal to 130 pi. We are taking pi as common, r square plus r square is equal to 130 pi. Pi and pi will get cancelled, the r square plus r square is equal to 130. We know that a plus b whole square is equal to a square plus b square plus 2ab. A minus b whole square is equal to a square plus b square minus 2ab. The plus 2ab and minus 2ab get cancelled. There is r square here, there are r square here, there are r square is there. That will become 2 r square plus r square. We are using the a plus b whole square into a minus b whole square formula. Then once that will be equal to 2 into r square plus a square. See, that's r plus r, the distance between the two centers they given as 14, that is 14 square, plus r minus 2 whole square. We are keeping this like that only. Then 2 times they have given just now we have found out that r square plus r square is equal to 130. Then we are substituting here, therefore r minus whole square is equal to 64. Therefore r minus r is equal to square root of 64, that is 8. Then we already know that r plus r is equal to 14. So when you add this, 2r is equal to 22. Therefore r is equal to 11. When you substitute that 11 here, we get r is equal to 3. The radius of the bigger circle is 11 centimeters. The radius of the smaller circle is 3 centimeters. Here, this formula we need not remember. You have to use a plus b whole square and a minus b whole square. Then 2ab here minus 2ab will get cancelled. We'll get 2 times r square plus r square, and use the given values and find out r and r. This sum was also similar to the previous sum. Only thing is, though in that previous problem the externally the circles was touching externally, here the circles are touching internally. Two circles touch internally. Sum of their areas is 116 pi square centimeters. The area of A1 and A2 is 116 pi square centimeter, and distance between the centers is 6 centimeters. Here there also 6 distance between the centers. Here also, here the distance between the centers, distance between the center of a bigger circle to the center of a this thing is, they are given it as 6 centimeters. We have to find out the radius r and r. So now we know that they have given distance between the centers. This is the r. From here to here, it is the radius of the bigger circle. From here to here, it is the radius of a smaller circle. Therefore, r minus r, bigger capital R minus small r, is the distance between the two centers. This is r, capital R. This is small r. This is the radius of a smaller circle. This is the radius of a bigger circle. Then the distance between the two circles is equal to r minus r. That means r minus r, they have given it as 6 centimeters. A1 plus A2, they have given it as 116 pi square centimeters. The area of bigger circle is pi r square. Area of the smaller circle is pi small r square. That is equal to 116 pi. When we take out pi common, then r square plus r square is equal to 116. As in the previous example, r plus r square plus r minus r square is equal to r plus 2 times r plus r square. R minus r is equal to 16 centimeters. A plus A1 is equal to 116 pi. Pi r square plus pi r square is equal to 116 pi. We have taken pi common here. R square plus r square, this pi and this pi will get cancelled. Then r plus r square is equal to 116. We are using the same formula here, r plus r square, r plus r whole square plus r minus r whole square is equal to 2 times r square plus r square. A plus b whole square plus a minus b whole square is equal to 2 times r square plus r square. Then r plus 2 whole square, we have to find out what is r plus r minus r is equal to 6 square. They have given is equal to 2 times 116. Just now we have found out here. Then r plus r whole square is equal to 196. Then square root of 196 is 14. R plus r is equal to 14. R minus r is equal to 6. So when you add this, 2r is equal to 20. Then r will become 10 centimeter. This is the radius of the bigger circle. When you substitute this here, then you get r is equal to small. This is the radius of the smaller circle. In the given figure, OAD is a quadrant of a circle. The radius OA is 3.5 centimeters and OD is 2 centimeters, and we need to calculate the area of this shaded thing. For that, we need to find out the area of the quadrant first, area of the quadrant. From that, we have to minus this area of the triangle. Then we get the area of the shaded portion. Area of shaded portion is equal to area of quadrant OAB minus area of triangle OAD. Area of the quadrant OAB, area of a circle is pi r square. So we have divided the circle into 4 parts. So to get a quadrant, we have to divide the area of circle by 4. Then 1/4 of pi r square minus half of base into altitude. This is the area of the triangle. So 1 by 4, pi is 22 by 7. This r is 3.5, that is the radius of the quadrant. Then 3.5 r square minus of, this is the base of a triangle. The 2 centimeter OD is 2 centimeters, is the height of a triangle. Then we can, once we calculated, we got the area of the shaded portion is 6.125 centimeters square. Triangle ABC is an isosceles triangle with ABC, angle ABC is equal to 90 degrees. A semicircle is drawn with AC as diameter. With AC as diameter, the semicircle is drawn. If AB is equal to BC, if AB is equal to BC is equal to 7 centimeters, find the area of the shaded region. So now we have to find the area of the semicircle. From that we have to deduct the area of the triangle, that gives the area of the shaded portion. So to find out the area of this triangle, we have of base into altitude. We know the altitude is 7 and base is 7 centimeters. To find the area of a semicircle, we need to find out r. So in that, because this is a right angle triangle, we can use it, that Pythagoras theorem. AC square is equal to AB square plus BC square, or AC is equal to square root of AB square plus BC square. With that we can find out r. By using that r, we can find out the area of the semicircle, that is half of pi r square. When we deduct that, when we deduct from that this area of a triangle, we get the area of the shaded portion. Radius r is equal to AC divided by 2. AC is equal to square root of AB square plus BC square divided by 2. That is equal to, they have given AB is equal to BC is equal to 7. That is 7 square root of 7 square plus 7 square divided by 2. Square root of 49 plus 49 divided by 2. 2 times square root of 2 into 49. 49 square root to 7. So 200 cancelled. Square root 2 can be written as square root into square root. One square root get cancelled with other square root. 7 divided by square root. This is the radius r of the semicircle. Then the area of this shaded region is equal to area of the semicircle minus area of the triangle ABC. Area of the circle is half of the area of the circle. That is, area of the circle is pi r square. Area of the semicircle is half of pi r square minus half base into altitude. Substitute the values. Pi is equal to 22 by 7. R, we just now find out that 7 by root 2 whole square minus half, 7 into 7. When you calculate this, we got 14 centimeters square. This is the area of the shaded region. A doorway is decorated as shown in the figure. There are 4 semicircles. One semicircle here, second one, third one, fourth one. BC is the diameter of the largest semicircle. BC is the diameter of this semicircle, of length 84 centimeters. This is BC is equal to 84 centimeters. The centers of all these small semicircles lie on this BC. ABC is an isosceles triangle. ABC is an isosceles triangle. AB is equal to AC. If OB is equal to OC, find the area of the shaded region. We have to find out the area of this shaded region. This. To find the area of the shaded region, we have to find out the area of this whole semicircle. Deduct this triangle, area of this triangle with this area of this. Then we get the area of this plus this. Then add this plus this with the areas of these three. These three are similar semicircles. So find out the area of one semicircle and multiply it with 3. We'll get the areas of these 3. Then we get the area of the shaded portion. Radius of this semicircle is, they have given BC. This is half of this. From here to here, it's going to be radius. 84 divided by 2 will give the radius. That is 42 centimeters. So this part is equally divided into three parts, that is each part, that is 84 divided by 3. 84 divided by 3 will give this distance diameter of each small semicircles. When you divide that diameter by 2, it will give the radius of smaller semicircles. So whole thing is BC, that is 84 they were given. So divide that into three parts, that will give the diameter of each small semicircle. When you divide that small diameter of small semicircle, will give the radius of this. So that using that we can find out the area of these semicircles, and semicircle and multiply with 3, we will get the area of this. To find out this, we can use the this R to find out the area of semicircle. To find out the area of triangle, you can use R is equal to BC by 2, that is 84 by 2, that is equal to 42 centimeters. This is the radius of the bigger semicircle. R is equal to BC by 3. This is the diameter of the smaller semicircles divided by diameter by 2 will give the radius of this smaller semicircles. Area of the shaded region is equal to area of the large semicircle plus area of 3 small semicircles minus the area of triangle of pi into r square of the circle, that is semicircle, r square plus 3 times. So we have 3 smaller semicircles, that is why we are finding multiplying with 3 times of pi r square. R is the radius of the smaller circle minus, this is the minus, we have to minus that area of triangle of base into altitude of 22 by 7 into, this is the radius of the bigger semicircle 42 whole square plus 3 times of 22 by 7, 14 into 14, 14 is the radius of the smaller circle minus that base of a triangle is 84, then into the altitude of the triangle is 42. Once we calculate, we get the area of the shaded portion as 1932 centimeters square. In the given figure, a circle circumscribes a rectangle with sides 12 centimeters and 9 centimeters. Calculate the circumference of the circle. We need to calculate the circumference of the circle and the area of the shaded portion. We need to find out the area of this shaded portion. So we have to find out the area of this circle. When you minus this area of this rectangle, will give the area of the shaded portion. To find out the circumference, we need to find out 2 pi r. We have to find out r. We need to find out r. To find out r, we have to use this. We have to use it as a hypotenuse of this triangle. This is 9 centimeters. This is 12 centimeters. AC square is equal to AB square plus BC square. So we can find out AC square root of AB square plus BC square. This will give this whole length. If you take this as a diameter of a circle, this gives that r of radius of that circle. Then 2 pi r is the circumference. So we'll find out. R is equal to AC divided by 2. AC is equal to square root of AB square plus BC square by 2. That is equal to square root of 12 square plus 9 square divided by 2. That is equal to 225 square root of 225 divided by 2, 15 by 2, 7.5. Circumference is equal to 2 pi r, 2 into 22 by 7, 15 by 2. This 15 by 2 we are using here. This equal circumference is equal to 47.1 centimeter. The area of the shaded portion is equal to area of the circle minus the area of the rectangle. Pi r square minus length into breadth. Pi is 22 by 7, r is 15 by 2 into 15 by 2 minus 12 into 9, that will give 176.625 minus 108. Then the area of this shaded area is 68.625. So circumference is 2 pi r. The area of shaded region is area of the circle minus area of the rectangle. Here we need to find out r, the radius of the circle, by using the Pythagoras theorem. AC square is equal to AB square plus BC square. Therefore AC is equal to square root of AB square plus BC square. AC is the diameter of the circle. When you divide that by 2, that will give the radius of the circle. So when we got it divided by 2, we got it 15 by 2, that is 7.5. Substitute it here, we got its circumference. Then area of the shaded region, pi r square minus LB. When we calculated, we got the answer as 68.625. ABC is the equilateral triangle of side 24 centimeters. We call side as A, that is equal to 24 centimeters. Circle is inscribed touching its sides. Circle is inscribed touching all the sides of a triangle. Then we have to find out the area of the shaded region. The area of the shaded region is equal to area of the triangle ABC minus the area of this encircle. We know that for equilateral triangle, the height is equal to root 3 by 2 of a side. The root 3 by 2 of side is 24, that is come 12 root 3 centimeters. This is the height of a triangle. Area of triangle of an equilateral triangle is given by root 3 by 4 times A square. A is the side of a triangle. Then root 3 by 4 into 24 square. Then radius of encircle inside the equilateral triangle is given by 1/3 of h. Then 1/3 of 12.3, that is equal to 4 root 3. This is the radius of the circle. By using this, we can find out, by using these values, we can find out the by using these values, we can find out the area of the shaded region. Area of the shaded region is equal to area of the triangle ABC. Area of triangle ABC is equal to root 3 by 4 into A square, substitute for value, minus the area of the encircle, that is pi r square, where pi into r is 4 root 3, r is 4 root 3, 4 root 3 into 4 root 3. By using these values, we can find out the area of shaded. The area of the shaded region is equal to area of triangle ABC, root 3 by 4 A into A minus pi r square, pi into r into r. After calculations, we got it. Area of the shaded region as 98.4 centimeters square. The figure shows the running track. This is a running track. Running track surrounding a grass enclosure. This is a grass enclosure, P Q R S T U. This is a grass enclosure. The enclosure consists of a rectangle PQST. This is consists of a PQST. This is a rectangle with semicircle region at each end. There is a semicircle region at each end. So this grass enclosure has got a rectangle PQST and semicircle enclosure at both the ends, with PQ is equal to 200 centimeters and PT is equal to 70 centimeters. Calculate the area of the grass enclosure. We have to find out the grass enclosure area. Given that the track is of constant width, this width of this track is 7 meters. Calculate the outer perimeter. We need to find out the outer perimeter of this track. A, B, C, D, E, F. This is the perimeter. We need to find out the area of this grass, and we have to find out the perimeter of the outer track. To find out the area of the thing, we need to find out the area of the rectangle PQRST, that is area of the rectangle is equal to length into breadth. Then we have to add this semicircle's area 2 times the area of this semicircle, that gives the area of these two. Then if this is the diameter of PT is the diameter of semicircle, half of that will give the radius of this semicircle. 70 is the diameter, 70 by 2, that is 35 meters is the radius of this semicircle. By using that area of semicircle is equal to half of pi r square. Pi r square is the area of the circle. Area of semicircle is half of that, half of pi r square. We just now find out that is r is 35, pi into r square. When you multiply that with 2, we get the areas of these two. Area of this plus area of this will give the area of this grass thing. R is equal to 70 by 2, that is equal to 35 meters. Radius of each semicircle. Area of the grass enclosure is equal to area of the rectangle PQST plus 2 times the area of semicircle, because there are 2 semicircles, that's why we are multiplying with the 2. Then PQ into PT, length into breadth, plus or 2 times half of pi into r square, 200 into 70 plus 22 by 7. That this 2 and this 2 got cancelled, 35. After calculation we got the area of the grassed enclosure as 17,850 meters square. The diameter of each outer semicircle of the track, from here to here, this is the outer semicircle. The diameter of this is equal to this plus this plus this, this plus this plus this. This is 7 meters, this is 7 meters, this is 70 meters. 70 plus 7 plus 7, that is given 84 meters. From here to here, this is the diameter. Then radius r of this outer, radius r of this outer semicircle is 84 divided by 2, that is 42 meters. Then circumference of outer semicircle is pi into r, that is equal to pi r, because it is semicircle. If it would have been full circle, 2 pi r. Because it is a pi r from here to here, pi r is equal to 42 pi. Then outer perimeter A, B, C, D, E, F, that is equal to 2 into 200. This is 200 is the length from A to B and D to E. This is the perimeter we need to find out. A to B is 200 meters and D to E is 200 meters. Then from here to here, that is 42 pi. From here to here, it is 42 pi. 200 plus 200, 2 times 42 pi will give the perimeter. 2 times 200 plus 2 times 42h, because there are 2 outer semicircles in the perimeter and 2 sides on the perimeter. 2 into 200. After calculations we got it perimeter as 664 meters.